Okay, so as we have seen, there are three adjacent planes which are important and we must know about this. I will repeat from the last slide. The first plane we call the A3. A3 is that auxiliary plane on which we are finally drawing the projection of a line or a plane, which we cannot do in any principal orthographic plane. Okay, so that is called A3. Then there is A2. For example, the example that I had given you, in this case we had determined the projection of the line on the horizontal plane, and from the horizontal plane we are connecting the auxiliary plane by the projectors. So that horizontal plane or the plane from which the projectors will be drawn is called the A2 in general. Finally, there is a plane A3 because we also need the distances. You know the distances here, this distance and this distance we need, and we are collecting these distances from here. Okay, so the plane here is A1. So this is A2 and this is A3. So keep that in mind. We'll refer to these planes time and again. Now, what are the steps? If I repeat, very first step is for the auxiliary view, and I'm writing here auxiliary line. It can be also for an auxiliary, an oblique plane if I want to generate the normal view of a plane. So here it is an oblique line, an oblique plane. We want to generate the normal view. First step is locate the auxiliary plane. And how do we locate it? We know it with the help of the projection on A2. Okay, so we look for the A2 plane and look for the projection of the line on A2. Parallel to that is the edge view of A3. Number one. Number two, the distances. So we look for the plane which is A1. Now in this case, A1 and A3 both are orthogonal to A2. So I will say this way, in the given example which is shown over here, frontal plane is orthogonal to horizontal one, and the A3, which is the auxiliary plane, is also orthogonal to horizontal one. The auxiliary one is A3, horizontal one is A2, and the frontal one is A1. So this is the second step. Now using this, we will try to do normal view of an oblique line. Let's see some examples. So the examples here, first is this, let's say, and in this example I'm taking the planes as A1, A2, A3, A4. Either of these, A1, A2, A3, A4, they can be also the principal planes. But right now let's take the terms as A1, A2, A3, A4. Let in A1 and A2 I know the projection of a line. So this is the projection of a line known to us. But we know the line is oblique. So none of these projections are the true view. What we have to do, we have to determine the true view of this line or the length of this line or the normal view of this line. At the same time, second problem, we have to also find the point view. How we handle it? Well, as we said, that's the A1 and A2. On A2 we know the projection. So with the help of the A2, I will locate the auxiliary plane. So the edge view of the auxiliary plane is parallel to the projection. So what is the meaning of this? I have the projection here. So anywhere can be the edge view of my auxiliary plane. Let us take one such view. So if I take one such view, let's say this is the edge view, and also I call it as a hinged line because about that only we are turning open the or unfolding the plane. So right now the blue line that we see over here, this line, this is the edge view of the auxiliary plane. One more concept. about this, let's say between these two planes, this is A2 now, and this is auxiliary, or we'll say A3, and I see the edge view of that plane. So this edge view where it is meeting the A2, that becomes the hinge also, and about the hinge I can open it. So A2 and A3, they will come in same plane. If I open it, that means after opening, this area is of A3. So if I give it the name A3, so this is A3, A2 and A1. Alright, we have identified now auxiliary plane. Let us draw the projectors. So to draw the projectors, we draw these projectors from the A2. So this is the direction of the projectors. Now along these directions, say here, alright, where do we locate the ends of the line? Okay, this is what we have to do, and what we do in that case, we measure the distances from A1. So I will take these distances at D1 and D2 and put them here, D1 and D2, in order to locate the line. So let us do it. And if you do it, so here is the distance which I will apply here. So if this is D1, here also it is D1. Similarly, if it is D2, I am applying this D2 here. So point B, and that is how we will be generating the projection of the line, and this projection is normal view, or the line now is the true length. Now the second thing is, if we have this projection, this is normal view, and we want to now locate the point view. Alright, where the point view will be, as we had seen, in frontal plane, profile plane, horizontal plane, that's the line, and this is my auxiliary plane, and this line is being projected onto the auxiliary as a true view. Okay, so the true view which we see here in A3 is actually projection of the line on this. Where is the point view? The point view of this line will be somewhere here, and perpendicular, this plane, this auxiliary plane will be perpendicular to the line. How can I locate it? Because this plane is orthogonal to the auxiliary plane, which is A3. Alright, so with the help of this concept, we will identify. So the auxiliary or the point view will be along this direction. That's the direction of line or direction of line of sight, and we create again the hinge, or rather this is the edge view of another plane. As I said, auxiliary plane perpendicular to that is another plane. Again I can open it. So if I show you this, if this is auxiliary plane, this is the plane which is orthogonal to this, and on this I'm going to make the point view, because the line is now like this, so I can open it also about the hinge. So if I open it, this entire area now is of A4, another auxiliary plane. So on this we will be locating along the projectors. So along the projector, where do I locate the point? Is it here? Is it here? Is it here? Is it here? So to locate it, again, yes, we are making use of the same concept as we had seen earlier. So from plane A3, we have got A4 where the point view will be generated. We have A2 where we have the projection of the line. So here in the A2, I have the, now this A2, sorry, this A2 will become A1, this A3 will become A2, and this A4 will become A3, as per our terminology. So what we do, from A2 we draw the projector. We have done the projector now. This is the projector coming from both the points. Okay, and we will take the distance from A1. A1 means this plane, which is A2 in this case. Alright, So how much the distance? The distance is D. So for both the ends of the line are at same D. So what we will do, we'll apply this D here and we'll get the point view of the line. So this is the point view. So this is how we could generate also the point view. Alright, so make it clear what is the meaning of A1, A2, A3. In general, A1, A2, A3, the meaning is A3 is the auxiliary plane where we are generating a view. A2 is from where we are drawing the projectors. A1 is from where we are taking the distances. Alright, we will take this same and we'll try to solve one more problem. Now in this case, the problem is we are given the projection of a line, and as you will notice, we have horizontal plane and the frontal plane. Okay, and using this horizontal and frontal, we have to generate the true length, or we have to generate the projection of the line on the auxiliary view or auxiliary plane versus the normal view, as well as we have to generate the point view. Alright, let's start, or rather in this case we are making use of horizontal view, which is edge A2, and so in this case the frontal will become A1. Now we have to identify A3. Where is the A3? So A3 can be parallel to the projection anywhere, or any of these I can take. Let me take one of these. So if I take one of these, this is the viewing direction. Well, this is the hinge line, or we can say this is the edge view of the plane. So right now the plane is going perpendicularly inside the screen. Okay, and once we open this, so this plane is going perpendicularly inside the screen, and this is my horizontal one, and now I open it. So by opening, this is the area where my A3 will lie. Okay, if this is the case, now we will take the projectors from A2, which is the horizontal in this case. So I draw the projectors from A2, that is how the projectors are, and I will locate the distance from A1. So the distance is to point A will be this, and to point B will be this, and I will be transferring these distances here and here. Okay, let's do that. So if I transfer the distances, well, that's the first distance to point A, then the another distance to point B, and then joining these 2 points, I'll have the projection of the line. So let's say this is the projection of the line, and this is the true view now. This is the true view. Again, please notice the notations. Now I'm using A1, B, A1. That means the point A and point B on the plane A1. Please understand, as per our definition, this is A1, this is A2, this is A3. Okay, right now I am calling A3 as A1. I have given this my first auxiliary plane on which the projection is being made. Okay, but in order to define the basic, where from we are taking the projectors, where from we are measuring the distances, in that way, this is the auxiliary plane A3, from where we are drawing the projectors A2, from where we are measuring the distances is A1. Alright, only A3 in this case I am calling as A1. Alright, now to do the point view of this, if you do the point view, same thing, yes, along the projectors, this is the direction of viewing, and I will identify again perpendicular to that the hinge or the another auxiliary plane, and I will measure the distance here. This distance or this distance both are same, and apply here, and using this I will be generating the point view of the line. So this is the point view of the line. Okay, now in this case what we will do now, instead of the horizontal, we'll use the front view, the projection on the front view. We want to use that to identify the auxiliary plane. Method is same. I may go little faster now. Okay, so we have the projections like this on the frontal and horizontal. Now using this projection, I'm trying to identify now the direction of the auxiliary plane. Concept is same. So parallel to this projection, we will identify the hinge line. Okay, so just don't bother about this part, it is projection of the same thing on the profile. So this is the hinge line, or this is the edge view of the auxiliary plane. So what we will do from the, now as per our definition, this becomes A1, this is A2, and this is A3. So horizontal we are calling edge A1, frontal is now in this case A2, and A1, the name that we have given, is actually A3. Again, A1, A2, A3 over here as per the basic method. So what we do now, from A2 we are drawing the projectors. So these are the projectors that we have done from A2, in this case the frontal plane. Now the distances we will measure from A1, in this case from the horizontal. It can be also from the profile view, either case, let's say from the horizontal. So the distance of A, I'm applying here. Distance to the B, I'll be applying here. Let us do that. And if we do it, I will have the projection of the line. So this particular projection is the normal view. Okay, so here, as I have shown also, TL stands for true length or normal view. Now to make the point view of this, yes, again in the direction perpendicular to this, anywhere here or these sides, anywhere I will be taking another hinge line or another edge view of the plane, or rather the another auxiliary plane. And on that auxiliary plane, by knowing these distances which are same, I will identify the point view. Let us do it. The steps are very simple. So the purple line here is the hinge line or the edge view of another auxiliary plane. And as far as the name is concerned, I am calling it as A2. Though as per our definition, this is A3. Now this will become A2 and this will become A1. Okay, I will write this A2 in a correct place so that you understand what I mean. This is A2. If I draw these also to make it little clear, so this area is A3, this is A2 as per our definition for creating these projections, and now this is A1. Alright, these three, A1, A2, A3, how we draw the projectors and measure the distances. Now I will measure the distance. So the distance is being measured here on A1 and I am applying it on A3. So let us apply the distance here on A3. Once we apply, we get the point view. So if I show you the point view, that is the point view. If this distance is D, so this is also D. We will see now one more method in order to get the true length of this line or the normal view of this line, which is an oblique line. And this method is called the method of rotation. Let us see how does it happen. For this, I'm showing you a small animation again. This is the frontal plane and we have the horizontal plane. As we know, the frontal and the horizontal. Okay, the frontal and the horizontal. Visualize that. There is a line over here, an oblique line, and for this line, if you mark this line as A, B, it will have its projection on the horizontal as well as on the frontal. So the projection of this are like this. So this projection I can write as A H and B H on the horizontal. If this line is projected on the frontal, so these two ends are A F and B F. Okay, they are the projections of the line. Now, one more thing, visualize the lines that I am drawing now. What are these? These are equivalent to the projectors or other projectors. Again, one more visualization. That's the horizontal plane, that's the frontal plane. In between the horizontal and frontal, okay, this line we call the hinge line. So for a line which is down there, it has projection on the horizontal, projection on the frontal, and these points which are the ends of the line on the horizontal and on the frontal, they are aligned because they are the same points over here in this space, so they are aligned. So if I open these two, they can be joined by the straight lines which are the projectors. Okay, the same I'm showing you here. Okay, what we are going to do here, something little special. Let us see that. I will be now for this line AB, I will hold the end A, I hold this end, and I rotate this line in such a way that this line becomes parallel to the frontal plane. Okay, and when I am rotating it, there is no rotation in the vertical, rather the only rotation is in horizontal. So this end is moving in horizontal plane, but while it is being done, this end is fixed. Now this line is parallel to the frontal plane. Its projection on the frontal plane will be now normal view. So that's the important thing, its projection will be normal view on the frontal plane. But how to do it? Just visualize this. This line has a projection onto the horizontal plane. If in the horizontal plane I can see the projection which is this. So with the help of the projection on the horizontal plane, I can execute this rotation. You know what will happen? If this line, once it is rotated and made parallel to the frontal plane, that means its projection on the horizontal plane will also be parallel to the frontal plane or the hinge line. So I will make use of the projection on the frontal plane, horizontal plane, and rotate that, and I will make that, or I will make the projection of the line on horizontal plane by rotating it parallel to the hinge line or parallel to the frontal plane. Let us do that. So for the line, if we rotate the line, that is how physically the line is rotating. What is happening to its projection? The projection is also rotating accordingly, and now this projection is parallel to the frontal plane. The moment it is there, the physical line which is there, okay, the actual line, now this line once projected onto the horizontal plane will give me the true length. Let me do that projection. So if I project it onto the horizontal plane, that is how the projection is. Now few things we must understand here. How to locate the end, this. If this is AF and BF and we call this point as B-F, let us say. How to identify or locate B-F? So if you visualize this, the rotation of this line, if I rotate this line, say like the holding this fixed and rotate it, what is happening to its projection, the projection of this point B onto the frontal plane, the projection of this onto the frontal plane is moving along a line. Okay, it is rather oscillating, I can say. Okay, it is just oscillating like this. So wherever the line is, for example, if the line is here, it has a corresponding projection. If I rotate it, make it parallel to the frontal plane, the corresponding projection which was earlier there has just shifted in the same horizontal line. So over here BF and B dash F are in the same horizontal line in the frontal plane. Now we will make use of this concept, and this is how I can identify this line in red color, which is the normal view. Okay, the same thing I will show you now by one example. These are the projection planes, and we have the projection of a line on the horizontal and frontal. Like in the previous animation, we are making use of the same concept. Rotate the line so that it becomes parallel to the frontal. How can we do it? We'll have to rotate the projection of that line on the horizontal plane so that that projection becomes parallel to the frontal or the hinge line. So if you do it, okay, just don't bother about this right now, because in order to complete 3 projections I'm showing you here. Let's focus on the horizontal projection. So point B of the horizontal projection is now being rotated. So this is after rotation it has reached here. So if it is the case, B dash H, if that is the point, so AS B dash H is the projection of the line on the horizontal plane after the line has been rotated so that the line is now parallel to frontal plane. Well, where is the corresponding point? In the frontal plane corresponding to B dash H. We can locate it because we know B is only oscillating here as we do the rotation. So the B will shift its position only along this line. So we make use of this concept, and corresponding to the point here I will be locating it down here. Let's do it. So B dash H, draw the projector, and that's the point. So this point is now B dash F. So this line is now the normal view of the line. Once we have the normal view of the line, I can also generate the point view of the line. Alright, same thing we can do if I want to do the rotation now by making parallel to the horizontal plane. What we had done in earlier case, we made the projection on horizontal plane parallel to the frontal plane. Now I'm reversing it. I'm using the projection on the frontal plane, rotating that projection, making it parallel to the horizontal plane. Let us do it. Concept is same. Okay, same line, its projections in all 3 orthographic planes. Okay, so as I said, this particular frontal plane, the projection of the line, I'm now rotating it and making it parallel to the horizontal plane. Okay, so by doing it I have made it parallel to the horizontal plane. The moment it is parallel to the horizontal plane, its projection on the horizontal plane will be the normal view. So if I project it onto the horizontal plane with the help of the projectors, again how the end B will move as I am rotating it, B will move along this line only. Okay, as we had seen in the previous case. So with the help of this we can locate the end B dash H. So this is the now normal view of the line. Again with the help of this we can locate the point view as we have done previously. Now some more small terms, they are not very important. How do we record the bearing of a line? You can read it also here. If there is a line, say these are the directions north, east, southwest, and there is a line AB. So we call bearing of line AB. So direction is important. Bearing of line AB, in this case, first case of notation, we can represent it as N 30 degree east. So from north we are measuring the direction towards the east. Same thing we can do if the line is in some different quadrant. From south we are measuring the angle now towards the west of line AC. Okay, similarly we can do it for another line which is AD. So once the line is in first and the fourth quadrant, we are showing the direction from north. Once it is in the second and third quadrant, we are showing the direction from south. Okay, and that is how it is represented. So very simple way, it's just for information. There is one more way of representation, that is called azimuth, or also called the whole circle bearing. In this case, the direction of a line we are observing always from the north. So how it is being done? So for a given line, its value is north 30, okay, from north 30 degree. For the other one, this entire angle from north, whatever that angle is, let this angle is 225, okay. Similarly for other one, so all the angles in this case are being measured from north, okay. So this is how the azimuth of the line or the can be represented. Well, we said that if we have a line, let's say there is a line, and for this oblique line I can determine its normal view. So the normal view, using our usual method, auxiliary plane, auxiliary view, we are doing the normal view or the true length. Once I know the true length, I can also determine the slope of this line now. So the slope of this line is, you can visualize it, you know what is happening here. The frontal, horizontal, then there is an auxiliary plane, and this line is inclined like that. So this line is now projected onto the auxiliary in the true view. So what is the angle? What is this angle? What is this angle of it? I can measure it on the auxiliary plane. So let us measure it. So if I measure it, that is how we can represent the angle of it. Okay, that's a simple thing. Alright, so with this, the things about the line we have completed. We will look for now how the rotations of the plane, or the same thing can be done for the plane also, in our next lecture. Thank you.